In this video, we'll be evaluating expressions containing reciprocal trig functions. Now first, let's look at the definitions. The reciprocal of sine theta is cosecant theta. The reciprocal of cosine theta is secant theta. And the reciprocal of tangent theta is cotangent theta. Our first problem is to evaluate secant 330 degrees plus cotangent 480 degrees. Now I want to draw reference triangles for each of these angles. (330 degrees), we're going to rotate counterclockwise and stop 30 degrees short of a complete revolution. So our reference angle here is 30. Now if we put our numbers in here, the hypotenuse is 2, the side opposite the 30 is 1, and then the other side is root 3. And since this side right here is below the x-axis, it'll be a -1. This one we need 480 minus 360, and so our angle is 120 that we're going to be dealing with, and that would be in quadrant 2. 180 minus 120 is 60, so our reference angle is 60. Again, let's put a 2 on the hypotenuse, and then the side opposite the 60 is root 3, and the other one is 1. This one is left of the y-axis, so it'll be a negative. Right, now, secant is the reciprocal of cosine. I always remember it because the s and the c are reciprocals of each other. So secant is the reciprocal of cosine. So cosine of my reference angle would be adjacent over hypotenuse. So the cosine is root 3 over 2. Now I just need to flip that over, and I can see that this term is going to be 2 over root 3 plus. On this one, we want the cotangent is the reciprocal of tangent. So our tangent of that angle is opposite over adjacent, which is root 3 over -1. So if we turn this upside down, the reciprocal, we would have a -1 over root 3. These have a common denominator, so we can go ahead and combine those at this point. We have 2 plus a -1 would be 1 over root 3. But then I need to rationalize that. And we could have rationalized at this point too. My answer on this expression is root 3 over 3. Now in this one, we have our angles in radians. Our reference triangle, this is a -3/4 of a pi. So our rotation is going to be clockwise. And we're going to just do 3/4 of a pi. Remember, pi is a semicircle. So our angle is in quadrant 3. Whenever the denominator is a 4, we're dealing with a 45-degree reference angle. And so if I put my numbers in here, I have 1, 1, root 2. When it's left of the y-axis, it's negative, and when it's down below the x-axis, it's negative. So this is my reference triangle. Now on this one, I'll think of 11 pi over 4 as 2 3/4 pi. So my triangle then, it's a positive rotation. 2 pi is 1 complete revolution, and then 3/4 of a pi puts me in quadrant 2. The reference angle is 45, and I have 1/√2. When it's left, it's negative, and up above, it's positive. Alright, so cosecant is the reciprocal of sine. So my sine of a negative 3 pi over 4 is opposite over hypotenuse. So that's a negative 1/√2. So in this expression then, I have 2/3 times the reciprocal of this fraction would be a negative √2/1. And then subtract. My secant is the reciprocal of cosine, so the cosine of this angle is adjacent over hypotenuse, so that's negative 1/√2. So when I turn that upside down, I have a negative √2/1. Here we have a negative 2√2/3, and the 2 minuses here is a plus, so it's plus. And I'm going to need a common denominator, so I'll just multiply top and bottom here by 3. So plus 3√2/3. Now I can combine these. They're like terms. They're both square root of 2 terms. So I get a negative 2 plus 3 is 1 square root of 2/3.